It's not very often I get excited about seeing some sort of old amplifier in the junk shop, but when I saw the front panel on this one, it was instantly recognisable in this 19-inch rack with a power switch and the heatsink on the front as a Kit amplifier. And I was hoping it was actually an AEM 6000, but it turns out this is actually the 1981 ETI 5000 series. I think it's a Project 477 or something. So it was only $20 blowing the fuse or something. So I thought for that price, just if any of these Mosfets are any good, it's got the Hitachi Mosfet output, it's worth that alone. I don't think that top cover really fits it properly, but this is, I think, the original case for one of those. And like I say, I think that top cover is unoriginal, doesn't really seem to fit, so maybe they got it like this and found some other cover, or maybe someone bent something else up. Those aren't the original type of caps, I don't think. This has got a couple of massive Sprague ones, or Sprague, or however you say them. Looks like the sort of things you used to get in mainframe computers, but a bit higher voltage. These are 22,000 microfarad at 75 volts, made in America, so that's, since most of the mainframe computers were made over there, that's where they came from. What have we got there? Just some bit of dirt. But looking at, I had a quick look at the circuit for these. These came out, I think, 1981. Electronics Today International. And if the Mosfets are gone, it should have blown these little fuses, which aren't gone. So I'll have a look and see what's going on in this thing. But yeah, it's really cool to get one of these. These were like about a $300 amp back in the 80s. So well beyond, I was only a kid back then, so well beyond what I could afford. But they had really good ratings. Really nice amplifier, basically, just designed by David Tilbrook in Australia. And he made some really nice stuff. He made a really nice preamp to go with these. Again, you build as a kit. I think that was nearly $300 again. So it was $300 just for the power amp. And I think J-Car had a slightly upgraded version for a bit more. I had a look in the old Dick Smith catalogues and they didn't actually sell this by the look of it. I thought Dick Smith sold these kits, but they didn't. Mostly just Electronic Australia Playmaster kits. So there's more J-Car and stuff, so I must have seen them in the electronics magazines of the time advertised there. So yeah, nearly $600 odd, I think. If you got the J-Car upgraded amp with the preamp, it was about $600, which was quite a bit in the 80s. But these were a superb amplifier, better than a lot of the commercial stuff you could get at the time. So we'll have a look and see. I assume there's a great big short circuit across the DC here somewhere. So we'll go across these capacitors. Yeah, that's charging up a little bit. So that is coming up slowly. Probably got pretty low resistance across them. I guess the other thing could be this bridge rectifier here. That seems to be okay. Is that going to charge up? That does go up. I think I'm charging it the wrong way there probably. But I don't think we've got a short circuit here anywhere. Let's go the other way on that one maybe. So it could be something in the output stage, but looking at the circuit, these fuses on the amp boards are designed to blow just if the Mosfets go. Pretty much everything else is unfused. So that's pretty good. Check across the speaker outputs maybe. So there's nothing obvious short circuit there. I doubt the transformer is faulty or anything, but you never know. It could have been cooked or something, or maybe they were just putting the wrong fuse in there. I don't think there's any rating given here. It's because it's all kit parts. There's no labels on anything. Oop. Where did that go? I thought it says no fuse, but what did they put in there? 5 amp, I think that is. Probably a fast blow too, so I'm not sure. It has kind of splattered a bit in there, so that's not the best sign. Just double check that is open circuit, but it looks like it's blown through. So even a slow blow, quick blow 5 amp you would hope would be fine. So what have they done here? They've run monster cable. Probably the best use I've seen of monster cable is actually power rails in an amp. And these are 100 watt a channel, so it probably doesn't even hurt to use it for the speaker wires, since we're actually talking real power here, not some toy thing. So it's no real easy way to... Might have to unsolder from one of the pins of the bridge rectifier, maybe the positive there. There's no other easy way to disconnect. I mean, we could disconnect the filter caps, but I'm not sure that's going to achieve a lot. What have they done with these filter caps? They soldered that the negative rails are both soldered together and off to the amp modules and off to the bridge, no, off to the speaker terminal. The original had 2 transformers in it, which I thought they said they put them, well, maybe they were center tapped, and they also put them in parallel, I think, so that's probably what's going on there. That should be alright. And yeah, I can actually take the bottom off this thing, I think. Yeah, there we go, got like hexagonal Allen key type bolts there, I think. Okay, yeah, someone seems to have added a lot of capacitors. I'm not sure they're original. There are caps tacked all over everything. ITT capacitors, that's a bit of a worry. I'm not really a fan of their stuff. All good. But yeah, whether it's just to reduce noise or something. Supposedly these were designed pretty well as long as you got the earthing right in them. Oh dear. Huh. That's charged up or done something. Seems to get going. We're measuring a bit different on that channel, but maybe I've got the multimeter in the other way. But like I say, I think the fuses on the board should blow. Okay, it's got ETI 477 power module. These look more like homemade circuit boards, but whether they really are, they could be kit ones. I think you could buy just this module part, or you could buy the whole case and stuff all together. So there's not really much sign of any issues in this thing. Now it's possible 5 amps too small, but these ones rated at 250 volt. Well, that doesn't tell me anything useful, does it? I can barely read the things. No idea what that says. I guess I should have probably printed out the circuit of the thing, so I know what I'm dealing with, but I didn't expect the fuses to be unreadable. These fuse holders are tight as. But it'd be very nice to get this thing going. This says 250 volt again, I think. Probably the most useless fuse stampings I've ever seen. I don't know what that says. So no idea what rating the mains fuse should be, but I guess 5 amp or something's probably... But a slow blow would be better. Might as well put a 10 amp quickie in there and see if it does anything. Shame they're still using 3AG fuses. I'm probably better off upgrading that fuse holder to something more modern. But it really doesn't look like there's anything wrong with this thing. But until you power it up, you don't know without fully disconnecting the bridge rectifier and stuff. Could be leaky diodes or something. But usually when the bridge rectifier is shorted, that fuse will really be black inside and have evaporated metal all over the inside of the glass and stuff like that. So I'll get this old power cord stub and hook up a lead to it. I think we'll just plug it in and see what it does. Could go via a lamp or something, but I used to just test things and then plug them in most of the time. And pretty rare, if you do the testing properly, pretty rare you have any problems. I mean, obviously with old valve gear and that, you never know. Something hasn't been plugged in for many, many years. I mean, we don't know when this one was last plugged in. I mean, this is basically a 40-year-old design now as well. But I guess we can plug it in and see what happens. Whoop! I took out the circuit breaker. So something's not happy. Okay, let's measure across the mains, I guess. No. Resistance would be more use than voltage. 0.8 ohms. Yeah, that's a little on the low side. Definitely got neutral to the switch. Cool, don't tell me the transformer's stuffed. It certainly looks like it could be. I doubt the switch is shorted out or anything, so it's not much else it can really be. And the only thing it can really be is the transformer, which would be a bummer if that's fried, because that is a very high power transformer. But it's not impossible that it's gone. I'd hate to think the replacement cost of that thing, but it's probably worth it to get this thing going. I do have another amp of a similar design of this somewhere, which I think might have had some blown outputs, but I'll have to dig that out, I think, and see what's going on with that. Might have a good transformer for this one, if nothing else. Certainly have to have something similar. So ohms from there to there, yeah, 1 ohm. I think that's a bit low even for a big power transformer to be that low. And given there's no obvious shorts on the secondary, of course we've got a separate winding and stuff here. Let's measure the resistance of the secondary of the transformer. That could be low, but I don't know if it should be even that low, but it may be 0.02 ohms. I mean, that is big thick wire, and there's not many windings on it, but the primary. But another thing could be that someone's damaged something with this clamp on the transformer, or some crazy thing like that. I think we're going to have to pull this off and have a look. It's going to turn it on the other side as well. Get another shifter. It's a hex head thing, isn't it? That would be typical. That's him. I don't think it's got a bit of tape there, it's stuck to the rubber, but I don't think it's been cooked badly or anything, which can be part of what will make the windings bad. But usually the primary winding will go up in circuit before it'll do much else. All looks to be good, no obvious insulation failings or anything like that. What have we got here? LP transformers, made in the UK. Type something. 3953, serial number 420. So I don't know if they're known for failing in the primary, but that does seem way too low even for a high power sort of transformer. But the only other option is just to disconnect this from the, in case there's a leaky diode or something. I don't think it's going to give us any joy, but you never know. But that 10 amp fuse obviously was close enough to the circuit breaker to pop the circuit breaker first. Operated a bit quicker than what the fuse did. The only way to be completely sure is to remove all load from the transformer. And really I'm going to have to do the other side as well, just to be certain. Doesn't matter that just if then it's just the center taps are joined together, which shouldn't bother anything. Unless someone's like wired the, well, it doesn't matter, there still won't be a circuit there to do anything. Unless, you know, I guess the other thing is if someone had wired the two sides of the one winding together, that would be the only other way you could stuff it up. Now, I don't think there's anything to show. Well, I guess we can check with the multimeter that both these other wires are connected to the center tap. Then it has to be wired up correctly. It can't be both wires off the one winding on the transformer, because then the other two would be joined to each other and not to the other bit. Out you come. Ah, it's gotcha. So the grey went to, or it doesn't matter, it's AC anyway, I don't think it matters what way we hook those around. Okay, multimeter time. Let's beep this out. They go to the bottom connection of these two caps. They're both connected to it, so it can't be the one winding joined together there. And I guess to extra prove it, we can check the resistance, even though it's going to be super low anyway. It's basically 0. That's a bit insane. Everything about this transformer just measures nothing. Now maybe because it's a toroidal, it's a bit less copper in it than the usual E-core kind of transformer. Don't remember them being that way, but I never dealt with a lot of toroidal stuff, so it was generally used in this sort of stuff, which you didn't see that much of. There was, I think, a Tyne television that used a toroidal transformer, and that was about it. They were a rather unique design. I only ever saw one and it was already written off by someone else. So I think I sort of saved it from going to the dump for parts, but I think I ended up throwing most of it on the dump anyway. The transformer probably went in the scrap metal or something. And that was about it. Okay. Let's go back to a 5 amp fuse. And since it's got no load on it, I can probably go even lower. I might even put a couple of amp fuse in there. I guess at least with a 5. We know for sure it's nice. Yeah, 3.15s, I've got plenty of them. Let's put one of them in there. It'll have a bit of inrush current, but it shouldn't. Let's hope it doesn't blow the circuit breaker again, because that's a pain. I've got a circuit breaker right next to me here, but it didn't bother blowing that one. I think that's only an earth leakage anyway, that one. Oh, here goes nothing. I've got no light in that switch, which I would have thought would light up. So power's on. So maybe it isn't a secondary. Well, that switch ain't on at the moment. And it's not on again. Oh, on volts DC, that wouldn't help. Volts AC is what I want. Yeah, I would have thought that down position should be on. Okay, as it popped the fuse in. There's always the continuity across the pins. Yeah, it's blown the fuse, I think. Expect to see something happen, but oh yeah, we've blown the end cap off the thing. So I'll say that's shot. So I think we've got a dead transformer. Shame that other one's a higher voltage, because that would have been, these are only 35 volts a channel, I think. Which would have been great. I better check these fuses are actually legit and not some junk. But at least with the lower current one, it seems to pop it straight away. Better than blowing the circuit breaker anyway. So let's just check. We've got circuit in place. No lights, so I'll say we've popped it. Yep. Yeah, well, that's annoying. I wasn't thinking the transformer would be blown. Of all the things that could be dead in this, I guess that's good because it means the rest of it's intact. Yeah, I don't know what I can do to... There's nothing I can really do to fix that, other than unwinding the whole transformer. Yeah, what a place to fail. You'd think these things would last forever. It'd be nice if I could read what the type number is. Just in case I need it, I probably won't, but... If I get this down, of course the tape right over the part you want is gone yellow. There we go. Type 82018, I think it says. Yeah, 82018. That's an ICP. And unfortunately, again, it's a European part that's failed again. I wasn't taking much notice of what was written on this thing. I thought it was just the voltages, but this does say primary 2.6 ohms, secondary 0.24 ohms, and it is a 35 to 30 or 70 volts center tapped, I guess. But yeah, someone has actually written a original resistance measurement, which is now long gone, so at least we know it probably is definitely a dud primary. I would have thought it'd be something like that. It should be a bit more than under an ohm. So I'll go and see if I can find any info on this thing or a replacement and what it's going to cost. Okay, I couldn't find any original specifications on this British transformer, but there's some talk about them online. But I'm not sure. I think there are even some new ones you can still get, but nothing to tell you what this 82018 type number means. But I looked at the Electronics Today International articles on this amp, and they're saying with the two original Ferguson transformers in parallel that they had, you can get around 100 volts at 7 amps continuous. So that'd be something like a 700 watt transformer, I guess, would be equivalent. You can get a 35A35, about a 500 VA, which is about the same as watts. But that's, you know, you're looking about $160, I think, plus postage on that. So not cheap. So I might see if I can find another transformer. Must have something here with something similar in it. And if I can at least power this thing up, even one out of like a old surround amp or something. And if I could at least get this thing powered up even with a lower current transformer that won't run this thing up to 100 watts, it'd be nice to just hear the thing, make sure it works. make sure everything's good in it before sort of committing that sort of money to getting a transformer that is probably even a little bit underrated compared to the originals. Not that I really want a 100 watt amp to crank right up or anything, but it would be nice if we could get this thing going at a reasonable wattage. So I'll see what I can find. Here I have this amplifier, which has got a homemade job out of some kits, and it's basically got an ETI 481 100 watt module there. Also got the proper power supply, which is in a 48 something, I think, maybe a 480, I don't know, but there is a power supply. And it's also got this all these pots in the front are basically a graphic equalizer, 5 band, and that's this board here, which is, I have written on it what it was Electronics Australia 1984, and it was, I think, a video sound processor kit. But what I'm basically interested in at the moment is it's got one of these M0144 transformers in it, which I'm not sure if that was just a Dick Smith number or a general transformer number like Ferguson's or something, but I think other people did sell them under the same number. So I think they were a transformer you could run like at least one of these 100 watt modules or 2 of the 50 watt ETI 481 modules. What I'm actually interested in is the voltage this thing puts out, because I don't think it's too high. Hey, it looks like it's like 28 volt, and 28 volts, about 60 volts center tapped. So this might do just as a test one for that ETI 5000 series. I think these were good for a pretty good current. It'll certainly do, you know, without turning the amp right up. So what I might do is actually pinch this out of here. But if I undo the, I guess the other thing would be to just plug this into the 240 volts and hook the, it might even be easier to hook the fly leads across. So we've got this, the orange, the yellow center tap. I might just have to mark these. Okay, so we'll do that. We've got our 3 wires. I'll get that other amp. At least I can test it and see if it's worth putting a new toroidal transformer into it. Oh, that's got a bit of weight in that thing. So let's have a look. I did actually partly disconnect this, yeah, that's okay. So yeah, we've got the bridge rectifier, which I could just hook onto if these leads will nearly reach it. What's too after? I guess I could use clip leads anyway. And someone's made a big mess here. Or do I even need to disconnect that transformer? I can probably leave it there. Just got to be careful, because potentially, well, this one's open circuit or shorted. Because there's always a chance if you put a voltage into one of these transformers on the secondary, you'll get 240 volts back out, which is not good when you've got these wires hanging out the end here. But I guess if you don't turn the power switch on, you'll be alright. So yeah, I don't think there's much point actually disconnecting that necessarily. Just wonder if I can reach these across far enough. Oh, we're getting awfully close. So we want the center tap obviously to there. I might just solder it on. Geez, I need some more solder soon. See if I'll probably need to turn the Hacko up a bit to solder onto this stuff, but should be able to meld into it a bit. And that's the yellow wire as our center tap. Only just enough heat there. Probably will need to turn it up a bit, but that'll do. And if we put the other ones on either side of the bridge, and hope that I definitely got these hooked up right. I should really check it again, but I'm pretty confident that's all good. Don't all the voltage across one channel or something, probably won't do it much good. That transformer would probably almost be enough to run this thing, just if you're going to not use it at full power. Now we need an input, a variable input, I guess, again out of my CD player, headphone connection. Well, that might be a bit premature anyway, but let's get that into one channel. Better get set up to check this quickly across the capacitors at least. Make sure it looks like we've got a reasonable voltage there and we're not about to pop anything. So that's going to cost that cap. Plug the other amp in and we have 38 volts. Guess I should check the polarities right too while I'm at it. I mean, it shouldn't be wrong, but which terminal's positive and negative? You think they would have marked these things, obviously. Oh, come on. Seriously? You've got enormous electrolytics, but no one can see which one's negative and positive. That's brilliant. Oh, these Americans are thinking, but maybe they're hidden under, oh yeah, it's hidden under the wiring, so I can't really blame them for that. Someone, of course, has put the wires right over where the terminals. I can't see it on the other one, so maybe only the positive is marked. So positive on the top. And we have a positive across it. The other one should be positive on the bottom, I guess, and negative, because that'll be the negative rail relatively. Yeah, and we can see the voltage dropping there. Yeah, 38 volts, all good. So this voltage will probably be a bit low for this amp, because what was it, 35, so it was 70 volts in a tap. That one's 60 odd volts. But now the next thing we'll do is speaker terminals. Oh, they're right there. I think this, did this have speaker protection in it? I don't see any, so maybe not. Oh, I think we're safe to fire this thing up. Let's see. Check that out without touching any of these bits of wiring. Ooh, we've got minus 38 volts there. That ain't a good sign. And 20 volts on that one. Well, that ain't a good sign at all. Do have fuses in here. You wouldn't think we'd be that far out. Now maybe it's, well, these shouldn't be capacitively coupled or anything, so I shouldn't have any voltage. That one's still 26, almost like it's at full rail. But that's why I check these things, in case someone's blown a channel. I don't think I even got as far as checking anything, because why would I bother, I guess. I guess the other thing we can do is check from the terminals here. To our filter caps, to our rails. We're not getting anything shorted. They're probably both connected to the other rail, to the centre tap. Now I'm tethered to this other thing to make life difficult. Ooh. Yeah, I don't know if we hook up a dummy load to those. I guess I could. There's a risk it will blow something if that DC is not meant to be there. But I guess that's the risk we take. Or I could just put 100 ohm or something. Where's my 100 ohm capacitor discharging resistor? I guess I could even hook that up, because I don't particularly want to dag it on there, because it might get awfully hot awfully quick. Let's just put that on one channel and quickly measure things. I mean, it should blow a fuse, I guess, if there is a genuine short somewhere. Didn't see any fuses blow, so it's something. Ooh, still saying 20 volts though.
resistor should be on as hell if that's the case. What on earth is going on here? Don't tell me my resistor's open circuit. Well, it probably is now. Hello, 114 ohms. I can't have 20 volts across it, surely. Without getting nice and hot. That's the thing there is. Yep, 19 volts across that resistor. Oh yeah, I think it is getting warm. Well, I think we've got issues here. So I'm glad I didn't spend like $200 on a transformer if this amp has other problems. I would have thought if it's got a faulty output though, it would blow a fuse straight away, putting a resistance even of 120 ohms across. You'd think it would upset the things, but maybe not. Well, that's down to about 16 ohms. Now, the thing is this transformer fused? I don't think it is, because I don't want to cook my transformer in this one. Although there are fuses in this which I think if the outputs do anything dodgy it should blow, but still I've got to be careful here. I don't want to open circuit primary in my other transformer. If this thing's got some issue with it, I think the best option might be to make a few measurements before I do anything more. It goes to show sometimes what looks like a simple fault, just a dead transformer, is not that simple. Now I guess we should check have those capacitors actually discharged. That one's pretty good, so I reckon they're going to be discharged. Good enough. I'll check these Mosfets. That's the... not sure, I can't call them collector and emitter. It's the gate and drain order. Well, that's a different one, so no point measuring that. So it's gate, source and drain of these things. Hang on, how are they set up here? Yeah, that's one pin. It's charging up whatever it is. It's the other one. With those caps across it, it's no wonder. No, didn't check the other ones. Oh, they're the opposite way around. Well, I don't think the outputs are dead. So where does the output come from? What's power and what is output? There's a big inductor on here somewhere, wasn't there? That'll be your output, which is here somewhere. But what's it connected to? I don't know. So this is our output here, I think. That would be our output wire. So this bit would be the other side, which I assume would come up to the source or drain of those things, or probably a combination of both, maybe. So what else is it connected to? There's three things. It must be these resistors. Yeah, so the resistors of the the Mosfets come out. That's the four of them there, I think, into this pad. Makes sense. That's then goes through the inductor to your speaker. What else is it not connected here? Some little capacitor and resistor by the look of it, and a couple of diodes. That's interesting. This has got a similar setup to that other amp. Wonder if they did copy from here. I should have a look into that, I guess. It's got two diodes, but they're both connected to the speaker. they're not in series, but then they go to some other diodes. Yeah, maybe it is the same. I was actually thinking that, should I look up the circuit of this thing to see if that other amp had copied it, and it looks like it might have. Yes, it's got bigger pairs of transistors. Probably a bit more powerful. I think they did say there was an issue with these driver transistors getting fairly hot in these. Yeah, so the drive transistors on this side look to be as dry as... Yeah, the joints are broken. Those two transistors are probably hardly connected at all. Yeah, the other one's just as... Well, it's got one pin at one end, two on the other one. But we can certainly start by resoldering all these, because that is definitely not good. I'm not surprised one of the channels is upset because of that. I mean, the pins, it's like someone's bumped on the heatsink and actually pushed all the pins, pushed all the transistors down towards the board and forced the pins to crack the solder. And maybe the way these heat sinks are mounted on the board is not good, and it's putting some sort of mechanical force on it or something. But I guess once you get these soldered, they should be without any tension or anything. But that is odd, the way they've really popped the solder off. It's not just your normal dry joint, I don't think. Unless they've been so hot or something that they melted it. Which is another possibility, that someone's had this thing cranked up to the max. Doesn't look like it's been overheated, but that would certainly kill your transformer potentially. It's usually what kills them. It's strange though, like I say, to go short in the primary rather than open, but it's possible the insulation broke down from too much heat or something, I guess. Yeah, those pins on that other channel, if anything, are a little bit short, I think. Okay, so, it definitely had an issue there. Is that capacitor fractured? Like I say, I don't like it when I see ITT written on things like capacitors, but that definitely has a crack in it. These caps are probably as good as those reefer things. But let some moisture in or something, that won't do things much good. It's definitely not shorted or anything. Not measuring any ohms there at all, so that's probably at least fine. It's not causing any issues in that sense. Now, I'm not sure what these transistors are, but let's see if we can measure some, make some sense out of them. Get a diode test again. 0.2. I'm not getting a lot of sense out of that one. This has got two pins joined, so it's going to be a bit weird anyway. I'll have to look the circuit up for these things. Surely that's the base. 0.8, 0.6. Not measuring obviously good. So it's possible having dry joints has popped something. It could just be resistors or something across it. That's 0.2 also, so that would suggest that there's nothing wrong, it's just the way this thing is. But both channels are faulty, so after resoldering them, I may have to unsolder them again. Is that another pair of transistors? I would guess it is. That measures like it should. That's probably going to be the complementary. No. Yeah, is there another pair somewhere? Yeah, over here maybe. Or not. Oh yeah, we've got something. Or do we? I'm only guessing. So what's on the other side of the board? Oh yeah, no, it is a pair of transistors there for sure. Oh wait, that's probably the base there, is it? 0.7, 0.7, yeah. More like a standard BC transistor. I'm thinking in terms of Japanese ones, which isn't much good in this sort of thing. So what? Oh, these are set up now. Oh, these are got two pins joined together. Whatever these were measuring differently, so unless they're like BC 337s or something. Oh no, they're on the heatsink as well. Oh, I didn't realise that. I thought we got another pair of transistors on the heatsink that probably want a quick check of their soldering. I didn't even click to that, I thought it was just a little pair of TO92s or something. I'll resolder them just to be sure. That one was a little bit iffy maybe, but not too bad. Yeah, whoever did these probably cut the transistor leads a little short. I like to have a little bit more sticking through so you definitely know you've got a good connection to it. So these seem to be alright. I forget which way around they measured now, but oh, come on, make a connection. Yeah, that's all good. Yeah, I might unsolder them. Probably won't hurt to get rid of that old solder completely anyway, given how fractured it was, but I don't think it probably matters. So that's likely the base. So that measures fine. I don't really need to undo the third pin anyway, do I? As long as two are disconnected, that is enough. Just sort of habit of disconnecting everything to remove the things, I guess. That's the other polarity, I take it. The complementary one. All looking good. So where was I getting that 0.2 or whatever across? That measures 0.6 or whatever, doesn't it? Nothing. 0.6, 0.6. Nothing. So they'll measure alright like that. So I've lost that. What, for some reason I was getting 0.2 across, but that's probably on the tracks here somewhere still, no doubt. Yeah, there it is. So what is that, this thing here? It's got to be. Huh? Say what? That is that. Goes to there. We've got 0.2 to that track. Now track's connected to one pin of that transistor. It's connected. Oh, maybe this thing's a resistor. Oh, it's going that way probably. I'm assuming it goes to the pin next to it, but it probably doesn't. Oh no. It goes the other way. So it looks like that's a resistor of some sort. 39 ohms. That comes across over here somewhere. back to here maybe through a 308 ohm. Well, I don't know. Well, those dry joints could have explained one of the modules playing up, but it doesn't explain the other one. I guess I could fire it up and see if one of them at least works. They definitely seem to be meant to be joined. Well, they must do something. Rather weird design, but anyway. Why would you have a transistor with two of the legs joined together there, unless they're using it for, I don't know, some sort of feedback, some sort of diode use, maybe heat sensing, feedback, something, I don't know. I guess the next thing here is to hook power back up. I might as well check it one more time. Though I have my doubts it's going to make the slightest difference. I've now got, yeah, dropping voltage on that channel. That's a good sign. That's got 0. What on God's earth is going on? Why would both of them be cured by fixing dry joints in one? Well, assuming they're cured, but... okay, that's completely insane, but anyway. Which one was it? That was flipped over, so that was the one that I was just playing on. That was the one with the dry joints, so the other one still has a little bit of voltage. But that one now doesn't have any voltage, so it was those dry joints causing that for sure. Can't hear the transformer humming, that's a good sign, because it's probably going to fry my other transformer if I wasn't careful. CD player going, hurry up. Don't know if anything's happening, but I guess we can get the oscilloscope on there and have a look quickly. Oh yeah, we got audio. Lots of it by the look of it. Excellent. So it's running into that dummy load, no problem. The other channel, there is 6 volts sitting there, so that makes me wonder, and it's climbing now. Maybe we have some other issue in that channel, but we've got one good channel. Let's put the oscilloscope on that one. That doesn't look too good. If I can make a decent connection to it, which is near impossible, of course. Are you connected? Oh, what have we got there? Ooh. I don't know. Is that some big gnarly signal coming out of there? Ooh, yeah, I don't think that channel's working too well. Okay, that's the point. We can unscrew them, can't we? No, what have we got going on? Just some sort of DC or rubbish coming out of that channel, I think. Fantastic. Well, at least we might have one working channel. Yeah, that channel's looking like it's plenty of cranking sound there. Well, there you go. This amp had other issues. Not that I'm shocked by that. But I think we're safe to hook a speaker up to that one. And for the first time in my life, I can hear what an ETI 5000 sounds like.
Okay, so that channel's good.
But we've got an issue still with the other channel, which is the one on this side. And looking at that, I can tell you what's possibly wrong with it. Is this heatsink here has been pushed down by the look of it, possibly on shorten the transistor legs. So both of these heatsinks look like someone's given them a right thumping. I reckon even just lifting that up might make some difference to it. But it looks like the heatsink was pretty much pushing on the legs. So that might want completely removing and straightening and redoing. Let's look that back up and just see if there's any DC on there. And it's climbing up again. It's doing something weird still, I think. Well, I guess I can put a signal in there and again hook the oscilloscope up, because at least that doesn't lie. Just see what we've actually got coming out of there, if anything. Now let's see if I can make a good connection. Something's not happy. Well, I think we're onto something here. It's always the issue with this second-hand stuff, is it's never known who's done what to it. But often people don't just chuck these things out, they have a fiddle with them first. This board here, and they had more problems. But I'm going to pull these off completely. I think there's some of the circuit board track with it. Might as well rip them out. Test the transistors, see if they're okay. Bend all the pins straight, make sure they can't touch the heat sinks. And go from there, I guess. So this is turning into, like a lot of these jobs, turns into much more of a job than it should have been. You'd think it was just an open circuit transformer. But I've seen enough second-hand electronics to not just trust things, because there's always the human factor. And that's often what you find when you buy stuff not working, is that someone's been in there and messed around with it and added their own set of issues. And also, you just can't make assumptions about did the transformer just fail or whatever, because you don't know the history of the thing. And even if it did just fail, did it fail because something to do with the load was out? So you're pretty much guaranteed you can't just replace it. Oh, look at these all bent like anything they are. Given how much of a hammering they've had, they may well have damaged the transistors even. Probably not, but like I say, you can't assume too much, but when the leads have actually been bent a lot, sometimes it can do some damage up into the transistor case. And disconnect something there or something, because yeah, these have bent right up to the transistor cases. Something you should avoid doing. You should never put force too close to the case if you can help it. May not worry it, but it's not good for long-term reliability generally. Yeah, really bent to the side, but they look like they were actually shorting on the case, but I don't think I actually measured these ones. Or did I? I did measure some stuff, so maybe they weren't shorting, but they were damn close.
waste off me pliers. Now let's just measure all these and also a chance to see what they actually are. What are they? BF 470s. And is it a 439? Yeah, 439, 470. Those are the bottom ones which measured good in both cases, I think. Should really test them for both polarities across the junction, especially when you're in this sort of situation. It's always between collector and emitter. Make sure there's nothing between collector and emitter in either direction. That's why your multimeter leads all end up in a knot, because you're doing this all the time, swapping leads over and over. Check between there and there, swap the leads over. Nothing, nothing, and check those as well. Nothing, nothing, check that as well. What's going on with this? The leads on this transistor seem to have been stripped of their coating, their tinning. Just make sure they can be tinned properly. Oh, yeah, they're all like corroded or something. Maybe just from being bent, it's flaked all the coating off, but it's like it's corroded underneath as well. Anything like that that doesn't connect well is enough to cause the sort of issues we got. Other side's a bit rubbishy as well. So, see, that's all those transistors. I guess I should check the others just to, while I'm messing around. 0.7, 0.7, nothing. Yeah, looking good. Yeah, well, these fit back in the board. They're straightened leads. Is there any other physical damage I can see? Oh, there's another transistor hiding there too. That resistor looks a tad cooked, but I guess that might be worth a check. Now these leads are probably going to be all over the place compared to the holes in the board. One seems to be a little bit out. Oh, actually I just spotted as a resistor there, it looks a bit cooked. So with those pins shorted out like that, of course, there's a good chance we could have fried a resistor or something. That seems to be open circuit. $22K, which given us could read something or other. I guess I should check a few around here because it's always possible. 270, 38 ohm, that's right, we come across that 38 and that 147 before. I better check, since this channel's faulty, I'll just check all these little diodes. Another resistor, is it the same value as that other one? Possibly. 1K. 1K ohm. I'm not really meant to be doing this today, but it looks like I'm stuck because of crappy weather. That's 100 ohm. Yeah, well, there's your 22K. 22K. Well, these two down here. Come on. 46, and I assume that's the same. 23, maybe because it's got the other one across it. Although then they'd both measure low, wouldn't they? Was I getting 23 out of that? Or was I was probably touching the other resistor. Yep, they're 47s, so that is open circuit. That would probably be our issue now that we fixed the transistors. We have an open circuit resistor. Just as well, it actually looked a bit cooked.
475. What's the 47 something? Where's that located? Right over there. Yeah, 470k. 3.3. 10k. 47. 270. 270. 3. 10, yeah. Just want to make sure they all measure the same as the other channel. 269, whatever it was. 270. Got one more here. Is a around 7k or something like that. Ooh, 17k there. It's going up. And this one also looks slightly like it's been hot. It's a nice 47 ohm, is it? Oh, 4.7 ohm, 0.47 ohm. One or the other. Gonna have to measure them from below because someone's put insulation all over it. .7, and where was the other one? 0. I should be a 1 ohm or whatever. I guess that's possibly got that inductor across it. And what did we say this other one was? 100 ohm. Yeah, 100 ohm. So I'll check the new one. It's definitely 100 ohm. Yeah. And it's not a metallized one, but I'm not that fussed about it. I just want to get this thing running before I worry about anything else. So that is, actually I'll that sitting there. One to this side, I think. So that is hooked to one of those transistors, so that would explain why it's, if those pins were shorted why it got cooked. Where is it? There. Yeah, definitely a brown mark on the board, or black mark on the board where it was sitting. Solder. Come on. And now the other pin moves, so I'll have to solder that again. Come on. Just to make sure I didn't make a dry joint. Chuck them away. Let's go the other way. Yeah, let's see if I can get these transistors to fit on the board again. It's going to be the fun bit. That side's not bad. Needs one pin there bending in a bit, and maybe that one back a tad. I think that side's a goer. And that end one goes in alright. It's now these other ones are the issue. Come on. Might be able to force them in. Oh yeah, here we go. Oh, I don't still got the one down the bottom end there. That's it, I think. Did that just go in? Oh, I definitely should have taken the transformer off this chassis. I think we've got everything in place by the look of it. Quick solder it before it drops out. But if I can get this end one in, it probably wants the other ones pulling back through the board a little bit. The leads are a bit longer. Very carefully like that. longer than they originally were, but anyway. That's how long they should have been in the first place, really. Someone did definitely cut them off too short. For my liking, anyway, I wouldn't have built it with leads that short. It's always nice when you've soldered the joint to have a little bit of lead sticking through, so you know you're definitely connected to it. Shouldn't be all covered up down in the solder somewhere, really. Bend that one a little bit over that way. Make sure it's well connected. I reckon this will probably go after this. Now that we've fixed the shorted pins and the open circuit resistor that resulted. Well, at least these amp designs, they don't blow the outputs when things like this happen, because you'd be up for a lot of expensive Mosfets if all these issues had caused problems. And I'll get power back up again, hopefully for the last time to test it. I might even put this transformer in this thing and give it a good run. I really would like to try one of these amps out and see what they sound like. As long as I don't crank it up too hard, that transformer should be fine in it, I reckon. Might fry the other transformer, because I really would love to have a listen to one of these ETI amps, because they were pretty cool back in the day. I just didn't realise they were so old. I mean, they're 81 or something, so I always thought they were like a later 80s thing, like with the ETI 6000 and stuff, but they obviously weren't. Okay, we've got that connected to the centre tap, blah blah blah. Plug it in. Okay, of course the camera died just as I got this thing fired up, but it does actually go in both channels now, though one of them seems to be a bit distorted. So we'll get it up and running again. But it's sounding a bit rattly. I changed the speakers over and it's changed channels. Connector's not the best. But this may even need like the quiescent current or whatever bias setting on it. It's just a little bit rattly on one of the speakers, and it seems to be the one channel when I change sides it does it need a channel, so I think there's something up with one of them. I guess it's going to be time to hook a sine signal into it. Sine wave, and see if we can crank it up and see what it does. Probably put the dummy loads on and okay, yeah, well this got variable output, hasn't it? So that's the main thing, because this is gonna, we don't have a volume control at all. Might turn that right down, so that should be putting that into there. And I think we'll get rid of the speakers because I want to be able to turn it up to whatever level suits me. And the other thing I want to do is fix this speaker terminal is loose. I might even undo the terminal bit. It's getting quite annoying. I'll try and get that. I don't think I can get a big pair of pliers in there. Try and get it tightened up. Onto the chassis, so that I don't have to keep dealing with it loosening off. It should do it. I think that's pretty tight. Oh, there seems to be something else wrong with these things. So yeah, so it's looking like some sort of damage happened to this, maybe because of that dodgy cover it's got on it, or maybe it didn't have a cover on it. Something's bashed, I think, both these sets of transistors around. Most likely been thumped by something. So that's the main cause of the issues. Now I seem to have fixed most of that, but I'm pretty sure this is still possibly a bit distorted. Now it may not be 100% happy running with this lower voltage, since this transformer can't get up to, I mean, on the filter capacitors when I've got 35 a channel, which is about what the actual AC out of the proper transformer should be. So it's a bit on the low side. That could be causing some sort of issue where the transistors can't operate in their normal voltage range properly or something. But the only way to test it is to put a sine wave in there and crank it right up. Make sure these dummy lathes don't touch on anything. And just the oscilloscope down a bit so I can really see this get up loud. White channel's looking alright. Other way. Maybe I need to try at a lower frequency. It looks fine. That's on the channel that was playing up too. No sign of any sort of distortion. Let's try the other side. That, on the other hand, looks like it might have some issue. There's something weird going on there. Oh yeah, the bottom of the waveform has some sort of issue. Very weird, like a little oscillation thing on the actual envelope. You don't notice it when you go up higher in the frequencies. And I don't notice it lower, so what's going on? Am I seeing some weird thing on the oscilloscope? No, it is weird, it hasn't gone away. So maybe it's even my signal generator's doing something weird. Yeah, no, it's gone, whatever it was. What sort of frequency were you putting out? 10 to 1000 hertz, so only about 70 hertz or something. Not sure what sort of level we're actually at. Let's crank it up a bit more. Best way to test these things is at a higher volume. Dummy lights don't seem to be getting warm. I think anything in the amp's getting warm. Transformer's humming a little bit, so it must be pulling a bit. Yeah, once I turn it back down, it goes quiet. But no, that's looking pretty good. So I'm not sure, maybe it's just something to do with the speaker or the something rattling or the actual CD player getting upset by the speaker, but putting a sine wave into this seems to be fine. Well, that's a relief. No sign of any crossover distortion or clipping at the top. Nothing seems to be running hot. Dummy loads are starting to warm up. No, I think it is actually working alright. Thank God for that. Other than it needs a new transformer, but I might pull the transformer out of that other one and solder it in here in place of that thing, just so I can give this thing a decent run. I'm not sure I even want to put that ETI 481 amplifier back together that much, to be honest, but then I've got to find something to actually run this. I actually need a preamplifier, something with a variable output, which I don't know if I've got anything anymore. I used to have an old preamp out of something that I use for testing these sort of amps, but that was a long time ago. Yeah, they're getting quite warm. No sign of any distortion or anything, so it might just be something to do with these speakers. Something mechanically rattling or something. Nothing running particularly hot in here. I won't touch the upper transistors because I don't know what voltage I got on them. Probably not that bad with this setup, but so the real test would be nice to hook it up to some speakers and give it a run with some music properly. Yeah, I think that'll do for the minute. About all like I say, left to do is I think we'll get that transformer mounted in this case. I've already got the, I haven't got all the secondary disconnected, have I? I'm gonna have to cut that wire off there, which I think all I'll do is snip it off. A couple of really big copper wires coming out of that transformer. Such a shame that thing's cactus. Because we've done solder it, and I'll probably have to cut the input leads off it as well, I guess. And we'll just use them to connect the new transformer to. It doesn't have very long leads, so I think I'll just leave a little bit of that primary connector there. But I don't think that transformer is much good for anything. Can't even get to the primary without unwinding all the secondary anyway. Oh, that's got some weight in it. So maybe that did get cooked by people hooking this up to some speakers in the faulty mode. That's all I can really put it down to. And running it with DC going into the speakers, and then it's actually overheated and cooked the transformer. Possibly you'd think it'd blow something else earlier, but sometimes the transformer primary is the weakest link. But in theory the fuses should be designed to pop before that happens, because they're meant to protect the transformer, since it's a very expensive part, and yeah, they are prone to cooking primaries if you're not careful, and as well as being a fire hazard and stuff. Is probably an even more important reason to look after them. Definitely don't want them overheating. Okay. Now this other channel definitely still has an issue in it. This one's fine. The one that had the burnt resistor in it makes a liar of me now, but if I tap the board, so it's more of a intermittent issue. Of course I just put the cover back on the amp, but there's definitely something up with it when you tap on it, which is interesting. So I'm not sure if that's something to do with one of those transistors, or we've got some dry joints in here or what, but of course probably when I had the oscilloscope hooked up to it, it decided to run perfectly. As soon as I put the speakers back on, yeah, it was distorting sometimes, and then I actually found if I tapped on it I could make it distort a lot. But anyway, it's getting it dinner time, so not sure I'm going to do too much more of this thing today.
But goes to show, no matter how much you persist with these things, there's always something still wrong with them. So maybe there's a crack in the board, or maybe soldering. Which amp channel is it? It's the one on that side, I think. Where's that resistor I replaced? I can't even see it there. Yeah, so it's this board here. Maybe there's some other... I can see a not so great connection there, but I think that's just been hot. That's interesting. I've still got power here somewhere. Seems so. Guess I should have checked if the caps were charged up or not, but some of the soldering in this channel's not the greatest, I must say. Is there even anything connected there? What are those pins? No idea. Oh yeah, there is meant to be some stuff connected there. I think. There's something there. Is that some little capacitor? Yeah, I'm not even sure there's something connected or not. If it is connected, it's not connected very well. And of course the solder sucker dumps a load of stuff. Yeah, that, whatever that's supposed to be. And there's nothing there. Where on the board am I? There should be some resistors there by the look of it. We've got a bunch of 5 resistors coming in this little area. Whoever cut the component leads, cut them awfully short. I don't know how you even cut your component leads that short. Get this solder sucker to clean out, I think, but you wouldn't know there was anything even in those pads by feeling it. It's that one comes through slightly, that one comes through slightly, that one is kind of there, but my god. That one isn't connected at all, I'm pretty sure. And neither is that one, really. So it's this little bunch of resistors here, and that one goes down better. Might have to replace them at this stage because they really don't stick through it. The whole boards aren't built like that. That's just asking for trouble. Yeah, I can see that one was already sticking through anyway. That one's definitely got a good connection. That one, yeah, not great, but I think there's enough there to do it. A good connection. That one was already through a bit, I could feel it. Still pretty tight. That one, god, yeah, it's there. Only just. And that one, is that really... I'm not sure, I can feel something, but I don't think it's a resistor. Where's that one go? Oh, it goes across that way. The transformer's coming loose. It's that one there, I think. Yeah, that little bugger there. God, the other side's coming. Oh, just pull it out. Whoever did this is just worst bloody soldering technique here. I don't know how you make your, how do you cut your component? Did they put them through the board and cut them and then solder them or something? Really weird. You come across some weird stuff. That's the problem with homemade stuff. That's the 10 ohm. Everyone's got their own weird way of doing it. Oh, I've actually got a proper 2%er or something by the look at it. Yep, 10 ohm. About the only one I've got, in fact, in the quarter watt size. Yeah, of course that one's not going to go through, is it? Because that's the one I just pulled it clean out of its solder. I didn't unsolder that side. So that's a really bad sign. That someone can't even trim the leads properly. So
I have to check each side of all these resistors, because I mean if I can pull them out of the board, that's a dry joint waiting to happen. This thing almost wants completely rebuilding. So much for getting to enjoy an ETI amp. So I guess I better probably check a lot of these connections in this thing and make sure there's actually a bit of component leads there. That one's not the best either. Is there anything there? I think we're going to find this thing's full of dodgy joints. Yeah, whatever that is barely connected, if connected at all. That side I think has something on it. What is that? That is a capacitor or something? No, it's a wire link. It's not even the wire link's too short. Oh, you gotta be kidding me. Looks like it's got plenty of lead there, but does it? Not great, but I think that'll do. Certainly wasn't expecting to have that issue. Whatever that is barely connected. I think that's a transistor. So what's next to that transistor there? It's a couple of resistors again by the look of it. Oh, so that's the transistor. This is one of the... It might as well not be connected at all. That's crazy. That one's definitely got a lead there. That's got one. That does too, I think, but... That does... There's just nothing there that I can see, unless I'm mistaken. It's basically level. I think it is just coming through. My fingernail can barely touch it. It is just through the hole, I think. And actually soldered still, but that's ridiculous. Now, which resistor is it? Second one there. But that's the sort of joint you could flick that out by hand, I reckon. Coming through is barely enough. God. I'm starting to think this thing's going to need a whole set of new resistors in it, really. Oops, I just tore the bloody track off too. Well, I didn't think scraping it with my fingernail would tear the track, but it did. I honestly can't tell if that's connecting to that part or not. Might have to change that one as well. That's just hopeless. Now, which one is it? That one, I guess. Yeah, that was barely through. Crazy. So it's a 22K, is it? Two, then brown, red, brown or something. I guess I'll have to take it at face value. I wouldn't be surprised if I've already fixed that intermittent fault, but I might as well check everything while I'm at it. Didn't think I was going to have to rebuild the whole thing, but it's possible that I will. That seems to have a lead there. I think it's mainly the resistors are the issue. There's another one that's... If that's another resistor, that's hopeless. just through. It's just ridiculously close to not being there. That side's not too bad if that is the same part. Even that doesn't feel. I mean, if you unsolder that, you'd swear that was just an empty hole. There is a little bit just coming through it. There's no obvious lead there. It is just a bit, but normally you'd spot the thing. So that's another one that just feels like an empty hole. That one has something, I think. That ain't much better. I think that's an empty hole too. There's something there, just very just. I'll have to push some of these through a bit further, I think. Yeah, this is just hopeless. So what have we got there? A couple of resistors, I guess. Yeah, those two resistors, I think. Well, they're stuck to something, so they must be through the hole, but you wouldn't know it to look at it. And this one's basically the same area, is the same. There's nothing there. So that was the good board. Yeah, there's just no lead that you can feel, or very little. That there's something, that there is something, that, where's that transistor? So there's nothing there. So I think someone's just basically soldered it, so there's just barely a... That's just absolutely everything on this board is hopeless. So that's transistors. When it's there, but God, only just... Okay, well, you can't see where someone's cut the leads off after soldering. So I'm pretty sure someone put these in, cut them to length, and then soldered them. Because you can see when a lead's being cut off, you've got that little sort of pinch thing where the side cutters went in, and the sort of bit of solder bitten off, and you can often see the lead inside the solder, because you've cut through the solder and the lead, and this doesn't have that. There's that capacitor in this one, and that's also not connected, or barely. So someone's built this in a very strange way, unfortunately. Probably someone who has no idea how to build a kit, but it can be fixed, just about. Yeah, so the leads are just sitting on the other side of the solder pad, I think, and barely into it. And yeah, all these ones are just hopeless. Definitely not how you should construct something. Yeah, that's coming through a bit better now. At least I can feel them there. Both channels are basically the same, but this one's definitely the worst. Like, hardly any of these resistors are through the board properly. I'm having to basically bend the leads as hard as I can against the board to get them to stick out the other side a little bit. And they're barely coming through at all. I don't think I've ever seen a kit built like this before. Of course, that was part of the problem. People building amps and stuff, they're musicians and whatever, trying to save a few dollars for themselves, which is completely fair enough, but not being very good at construction. These components are all just disconnected. Would have been easier to build it from scratch again, I think. So which one is it? This channel? Yeah, there's all these resistors. Oh, so that one's come off the board. I don't think I unsoldered both ends of that one. That's the right one end. And I think these other two. That is some crazy weird stuff. What have we got here? I think that one may have to be replaced. $150 ohms. Yeah, I thought something about the board looked a little odd, but it never really took much notice until now that I think about it. Of course, that one was one that fell out on its own. There's the other half there. But yeah, when I think about it, there's not a single cut-off lead visible in the solder. It's more like a pick and place machine's done it or something, which isn't normal for kit construction. That's got enough length now, that's got enough length now. Now what have we got here? Yeah, still plenty of stuff. I've hardly even touched the surface. What else have I disconnected here? That one, I think. So that might have enough length to go through. Now that one's one I've got loose, that's one I got loose, that's one I got loose. So yeah, what should have been a nice quick job has turned into a partial rebuild of this thing. Did that make a good join? Yeah, it did. I think I've gone over most of it now. I might resolder that, looks a bit iffy, so does that one for that matter. It's never tinned properly. That's got a pad or a pin. That's got one. That, yeah, that's no good. Yeah, no, that's definitely a nice connection now. Could be better, but it's there. Oh god, we got something loose here too. I think we've got a broken track there. This capacitor, yeah, it's actually busted the track. Capacitor's been bumped or something. Oh, that's barely a connection there too. Another resistor, no doubt. Yeah, that is one of those resistors down the front there, and so I need to just check we've got a resistor there, we've got a something there, so let's get a wire link over that while I think of it, before I forget where it is. So that might have been the main problem, and it's was that crack in that track. That's why I don't want all these caps hanging off the board everywhere, because yeah, they get physically bumped and they can do things like that. Oops, I better not flick my solder in that other amp, that's on the floor. The one I pinched the transformer out of. I'm going to get rid of that resistor too, that's just another pain in the bum. Which I think is that one, isn't it? No. Bloody, oh, it's on the other side probably. It's got this other silly capacitor in the way. Yeah, that's the one. Wonder cap. Wonder why the hell someone put it in there. Wonder what they were thinking. I guess that's the other problem. If someone doesn't buy a kit, they just go and buy whatever random parts they can get. That's another 47k. I assume they're just polyester type capacitors were meant to go in there. And these are some sort of probably audio full ones. Ultima series with Danor, D-A-N-O-R. 425 volts, what? Sounds like something you'd use for restoring valve equipment. Yeah, it's just kind of insane, really. Better check the ones on the other channel, I guess, make sure they haven't done any similar. Someone's already rewired around that one. Soldered wires across the board, so that one probably broke as well at some point. I hope this thing still works after all this, and hopefully works better than it was. I might even put a dag across that. Bit of solder across the other part of that track, just in case there's any other breaks or anything. Check all of them now. Oh, just another way to add trouble to things. Mounting all these random caps everywhere. I don't think they're part of the original circuit, or are they? Some may be. Yeah, some are mounted where there's holes in the board. Some not. Okay, I think that's everything. I think I got them all. Well, I guess we'll find out. All I can really do is I'll check the speakers aren't shorting out or anything. They're still, that one's disconnected, of course. I guess I'll just take the risk of hooking it back up with the speakers and hope nothing bad happens. Our channel's back in. Get the CD going again. Now I'll just plug it in and hope for the best. Well, good so far. Yeah, beautiful and clean sounding. Oh, I also replaced a handful of resistors there. Well, that's only about 5 of them or so. Chuck them in the rubbish. And there's another one, 6 or so. Seems to be good. So I think I'll have to hook this up to a good pair of speakers and maybe just wire up some sort of volume control feeding into it. And that's somewhat dodgy top cover for it. It's someone's homemade, and it doesn't really fit properly because the rubber feet aren't big enough. The actual ends of this are too long, so it must have been set up in a particular way for some particular usage, I guess. But it looks like it might actually go. I'll just be interested to see if it sounds any good before I spend any money on a proper transformer for it, if I even bother. I might even just leave that thing in there if it runs alright. But it'd be interesting to try it out and see what it's actually like.